Hi, this is Kumar Singh from Designed Analytics LLC, and you are watching another episode of Thursday Throwbacks. Well, the throwback or the historical milestone or the journey that we are going to cover today is the journey of time series forecasting. Well, if you have ever worked in the field of analytics, if you have worked in the field of analytics, you typically have done some form of forecasting, and that means you have at some point of time in your career worked on time series forecasting. So essentially your career has benefited from time series data analysis and forecasting. So what exactly is time series data, right? It's the collection of observations over time, and it's each data point is in a time series data is associated with a timestamp that sets the data apart. One of the earliest recorded examples of time series data is data pertaining to sunspots in ancient China as early as 800 before Christ, right? So that's where we started actually capturing time series data, right? Now, time series analysis basically shows us how the observations, the variables that we have captured over time have changed over time, right? That's the data part you have to remember, right? And we are basically, as we progress through the journey, the historical journey, we will also understand the forecasting aspect, because what's the point in having the data, the observations, understanding how they change over time, unless we can put them to good use, right? So as you can imagine, time series analysis is highly dependent on the quality of data available, like any other analysis, and it wasn't until the early 1900s that large amount of consistent quality data was emerged, or we were able to capture it that way, right? Obviously the data is also reliant on developments, not the data but the approaches that we used on the data is also reliant on developments in probability theory and statistics that we will understand, right? Like how it evolved based on the development in probability and statistics over time, right? So a very quick recap, right? What are different types of time series models, right, before we jump into the history? So one of the first models to attempt a time series analysis was the autoregression model in 1927, right? So this model made use of past values to predict future values using a regression equation, right? And this model was a building block for the autoregressive integrated moving average, I think ARIMA, if I remember it right, models later. So these ARIMA models that were later developed in 1970s by George Box and Jenkins, Box Jenkins. The simplest model of ARIMA model is ARIMA model itself, right? And the best way to understand is by breaking it into components. So there is this autoregressive component that uses past values to predict future values, right? And by doing that, it helps explain the long-term trends in the data, right? Then you have the integrated component, which basically replaces data values with the difference between the previous value and helps remove trends and seasonality in the data, and by doing that ensures stationarity as required by the model. Moving average MA, it uses errors to predict future values and helps explain sudden shocks in the data, right? It has become one of the most common approaches in time series modeling, right? So with that background, let's cover the timeline. Early foundations, 1900s to 1950s, right? 1900 statistical origins. So Andrei Kolmogorov and Norbert Wiener laid the foundation for stochastic processes and time series analysis, right? So Yule and Slutsky introduced early autoregressive AR and moving average models. Like we mentioned, these later it was refined by Box Jenkins, but the early models were basically formulated or introduced by these guys to describe sunspot cycles. Then if you look at the phase of 1940s to 50s, that's the control theory and engineering application phase, where development of Wiener filters and Kalman filters right, which were originally intended for radar and navigation systems, introduced recursive estimation for dynamic systems, right? And then we move into the classical statistical methods phase, which is 1960s to 1990s, and that's the Box-Jenkins era. Box and Jenkins formalized the ARIMA modeling framework that we just discussed, and that introduced like model identification, estimation, diagnostic checking as a structured modeling cycle. Then comes the Holt-Winters phase, the exponential smoothing, where this specific approach, exponential smoothing, introduced methods for trend and seasonality, right? And it gained much popularity in business forecasting, right? Because of the benefit it had over methods that did not take into account trend and seasonality, right? Which method is most widely used? I will say Holt and Winters method for handling level, trend and seasonality still is the most widely used in areas where we still use traditional or classic time series forecasting, right? Then we have state space models and Kalman filtering, right? It's used for applications in economics and engineering, and it laid the foundation for latent models like structural time series and dynamic linear models. Then comes the 1990s to 2010s era, right? Neural networks, support vector regression, and decision trees started being applied to time series, though often with limited success due to data scarcity and lack of sequence awareness, right? Then between 2000 to 2010s, Gaussian processes, random forest and ensemble methods gained traction for non-linear forecasting, right? Facebook Prophet, right? I think introduced in 2017, popularized time series forecasting for practitioners with its robust, interpretable, seasonality aware model, right? How did the deep learning revolution impact time series forecasting, right? So if you think about recurrent neural networks, LSTMs and GRUs, right, they became state of art for sequence modeling, right? And they are widely applied to multivariate and long horizon forecasting tasks, right? Temporal convolution networks and attention mechanisms are showing improved scalability and accuracy. Transformer based architectures, right? They can also help with efficient long-term forecasting like Informer, Auto Informer, FEDformer, FedFormer, however you want to say it, right? Concluding this historical journey is what's currently going on. So we are seeing a surge in foundational model for time series like Time GPT, Chronos, Neural Forecast, right? There is a focus on probabilistic forecasting, uncertainty quantification, multivariate and hierarchical forecasting, and self-supervised learning, and large-scale benchmarks like Monash time series, forecast repository, and competitions are driving progress. Well, that's all in today's episode of Thursday Throwbacks, covering the historical timeline of time series analysis. I will see you again next week.